Hello students, this is a video on the design of turnout using Cole's method. Let's start. So this figure shows the layout of a turnout. We can see the different notations here. First one is a curve lead, which is AE or TE dash. Next one is switch lead, which is TL. You can observe the notations in the figure also. Curve lead A, E or T, E dash. Similarly, switch lead is TL, lead of crossing is LE dash, gauge of track is AT or EE dash, angle of crossing alpha is the angle CEA or ECE dash. Heel of divergence is the distance LM. Number of crossing is denoted by the alphabet N and it is given by cot of alpha, that is cot of the angle of crossing. Radius of outer rail of turnout curve R is given by OE or OT. The point O is here, which is the center of the curve. So radius is OE or OT. OT is this distance and OE is here. O. So let's see the notations one by one. So to obtain the curve lead, there is a distance that is curve lead, which is AE or TE dash. For that you have to consider the triangle ATE. So distance ATE is G, that is the gauge of the track, and angle AET is half of the angle alpha by 2. That is angle AET is half of the angle alpha, that is alpha by 2. This is the angle alpha. So this angle should also be alpha since both lines are parallel, and half of that angle is alpha by 2. So if we take tan alpha by 2, you have G divided by curve lead. Curve lead can also be curve lead is given by G cot alpha by 2, and also we have curve lead is equal to E dash C plus CT. So that comes to G cot alpha plus G cosec alpha. Finally, it can be written as approximately 2GN. Then you have the switch lead. To obtain the switch lead, you apply the property of triangles. So by this equation, you get switch lead is equal to square root of 2RD minus D square. Again, lead of crossing L is given by the difference of curve lead and switch lead. Curve lead is equal to G cot alpha by 2 minus switch lead is equal to square root of 2RD minus D square. Radius of curve can be obtained by considering the triangle AOE. That is A. O is somewhere here and E is here. Okay. In that triangle, the right angle is at the point A. So we can write that OE square is equal to OA square plus AE square. O is somewhere here. So OE square is equal to AE square plus OA square. So that can be written as OE square is equal to R minus G the whole square plus curve lead the whole square. So that can be expanded as OE is the distance radius, that is R square, which is equal to R minus G the whole square plus curve lead is given by the equation Gn plus G into square root of 1 plus N square. So solving this equation, you get R is equal to 1.5 G plus 2 Gn square approximately. So these are the formulas which you derived in this design of turnout: curve lead, switch lead, lead of crossing, radius of curve, and heel divergence. So let's see the problem. A 1 in 8.5 crossover exists between two broad gauge parallel tracks with their centers 5 meter apart. Find the length of the straight track and the overall length of the crossover. Use Cole's method. So given details are capital D is equal to 5 meters, N is equal to 8.5 and G is equal to 1.676 meters. So first let's find out the length of the straight track, which is given by the formula D minus G into N minus G into square root of 1 plus N square. Here capital D denotes the distance between the broad gauge parallel tracks. The distance is given as the center to center distance, that is 5 meters. So this can be solved by substituting the values of D, G, N, etc. So finally you get 13.91 meters. Again, to find out the overall length, it is obtained by adding the length of the straight track plus 4GN. So that comes to 70.89 meters. So this is the problem you have to solve. Thank you.